In this lecture, we will define some terms connected to stresses and strains. Then we'll go and see the validity of Hookes law. And after that, we'll define some elastic constants. So first of all, we'll see conventional or engineering stress. It is denoted by sigma naught, which is equal to load divided by original cross-sectional area. So if we have a bar whose original cross-sectional area is equal to A naught and whose original length is equal to L naught, and at any time t the load acting at the ends is equal to P. So conventional or engineering stress sigma naught is equal to P divided by A naught. It is as simple as that. So the second term that we are going to define is true stress. It is denoted by sigma, which is equal to load divided by instantaneous area of cross section. This is equal to P by A if A is the area of cross section at any time t. So further we can write P by A as P by A naught multiplied by A naught by A, just by multiplying and dividing by same term A naught. Now I shall erase this first. Now we know the volume couldn't change on applying load, so the original volume A naught multiplied by L naught will be equal to the new volume at time t, A multiplied by L. Now we have to find A naught by A, which is equal to L by L naught. Now this L by L naught can be written as L naught by 1 plus epsilon divided by L naught. I'll tell you how we can write L naught multiplied by 1 by epsilon in place of L. Wait a minute. So epsilon, as we know, is the strain, which is the change in length divided by the original length. So change in length is L minus L naught. This is the change length. This was the original length. I'm just writing L naught minus, I'm just writing L minus L naught in place of L naught minus L, just to make it positive, divided by L naught. So this will be equal to L by L naught minus 1. So 1 goes in here on the left hand side. This becomes 1 plus epsilon is equal to L by L naught. So your L becomes L naught into 1 plus epsilon, which is used in here. So L naught gets cancelled out and A naught by A becomes 1 plus epsilon. So as earlier we defined the true stress as sigma, which was equal to P by A naught into A naught by A, and now we have found out that A naught by A is nothing but 1 plus epsilon. Now this P by A naught is conventional or engineering stress, which is denoted by sigma naught, and thus we have got this relation between true stress and conventional stress. Now let's move over to strains. First of all, we have conventional or engineering strain, which is equal to epsilon, and it is 1 by L naught integration of dl from L naught to L, which is nothing but change in length by original length. This is the original length. If you integrate it, you will get L minus L naught, which is equal to change in length. So this is change in length by original length. This was defined as engineering strain. Now we have true strain or natural strain. It is defined as the change in length per unit instantaneous length. So this is dl by L. This is instantaneous length at any point in time. So you'll integrate it from L naught, because this was the original length, to some length L. This will come out as log L by L naught. So this was your conventional or engineering stress and strain and true stress and strain. Now we'll move over to define one more term for you, factor of safety. Because of the uncertainties of loading conditions, a factor is introduced which is called factor of safety. Factor of safety is defined as the ratio of maximum stress to the allowable working stress. Here maximum stress is usually taken as yield stress. Now let's move on to define elastic constants. The first elastic constant that we are going to define is modulus of elasticity. Modulus of elasticity. For this we'll take help of Hooke's law. Now according to Hooke's law, stress is directly proportional to strain. A constant of proportionality is added between them, which is equal to modulus of elasticity. This constant of proportionality is known as modulus of elasticity, or also known as Young's modulus. Now we also have to see the validity of Hooke's law. The validity of Hooke's law, first of all, that it is valid till the limit of proportionality. Second of all, the load has to be axial. And then the bar has to have a uniform cross section, and it should also be homogeneous and isotropic. So these are the four assumptions on which Hooke's law is based. So moving on to the next constant that we are going to define,